Hi everyone, today we're going to be doing lesson 3 of unit B. We're going to be looking at first differences as rate of change. In this question, we're asked to determine if this relationship is linear or nonlinear and to explain how we know. We can determine this by looking at the first differences and seeing in our rise column whether there is a pattern or not. So if we look at the 5 to the 15, we can see that's an increase of 10. From 15 to 35, that's an increase of 20. Then from 35 to 60, that's an increase of 25. And from 60 to 90 is an increase of 30. Since all of these first differences are not the same, we can conclude that this relationship is nonlinear. It's not increasing or decreasing by the same amount, so the line on the graph would not be straight. This question is also asking us to determine if the relationship is linear or nonlinear and to explain how we know. We can see that the number of cookies left are decreasing by 10 each time 2 minutes has passed. This means that the relationship is linear. You'll notice that the first differences are all the same, -10 on the rise side, and they are all the same, 2 on the run side. This means that the relationship is linear. If a graph were to be drawn for this relationship, it would be a straight line. This question is asking us to explain why we cannot find the rate of change for this table of values. At first glance, the run side of this table does seem to have a pattern. You can see that the run side, or the independent side, relating to time is increasing 1 second at a time. The problem is that what is happening on the rise side of this table. You can see that from 50 to 45, that's a decrease of 5. And then from 45 to 43, that's a decrease of 2. But then from 43 to 49, that's an increase of 6. And then from 49 to 40, it's a decrease of 9. Because there isn't a consistent pattern in this right side, or the dependent side of our table, we can conclude that the relationship is nonlinear. Because the relationship is nonlinear, we cannot determine a rate of change. In this question, we're asked to determine the rate of change for this table. We can start by finding the run. We can see that the number of days is increasing by 10 each time. So our run will be 10. Our rise is found on the other side of our table, the dependent side. This is reflecting our balance. The balance begins at 50 and then increases by $15 each time 10 days have passed. This means that our rise will be 15. We can use our formula, rate of change is equal to rise divided by run, to determine the rate of change. When we do 15 divided by 10, we get 1.5, or $1.50 per day. This is our rate of change. To find the rate of change of this table of values, we'll look at how the independent and the dependent sides are increasing or decreasing. We can see that the distance in kilometers is our independent side, which would show us our run. And we can see an increase in 100 kilometers with each increment. On the right side, or our dependent variable, we see a decrease of 6 liters per 100 kilometers. So our rise will be -6 and our run will be 100. When we use our rate of change formula, rate of change equals rise over run, we'll have -6 divided by 100. This, of course, will give us 0.06 liters per kilometer, and that's our rate of change. Finally, we're asked to list 3 things we need to remember when finding the rate of change from a table of values. First, we'll need to make sure that there's a consistent pattern in both sides of our table. We need to see that the relationship is linear. So if we can find an increasing consistent pattern in the dependent and the independent side, we'll be able to find the rate of change. We can find the rise by determining the increase or decrease in the dependent, or the right-hand side of our table. And we can find our run by determining the increase in the data in our left-hand side of our table, or our independent side. Once we've done that, we'll use our rise over run formula for rate of change, and we'll want to remember to include units at the end. So we'll use our rise units per our run units, or our dependent units per our independent units.